In this problem, we have a rod of mass m and length L which is hanging vertically with point A, and the rod is free to rotate about the point A, which is the point from where the rod is hanging. A ball of mass m by 2 moving with the speed u strikes at the lower end of the rod. Now in the question it is asked that just after the collision, what would be the speed of the rod? It is also given that after the collision, the ball sticks to the rod. Now let us see how to solve this problem. Angular momentum of the ball about point A before collision. So this angular momentum would be, we know that it is mvr, so here it would be m by 2 into u into L. This is the angular momentum of the ball about point O before collision. After the collision, this small ball gets stuck at the end, and because of the impact, the whole system, say, moves with angular speed omega. Now, if the rod and ball system moves with angular speed omega, then angular momentum after the collision, it would be the sum of angular momentum of the ball plus angular momentum of the rod. So angular momentum of the ball after the impact would be mass, its velocity L omega into L. See, this is nothing but mvr. This is mass of the ball, L omega. See, if the whole system is moving with the speed omega, then the speed of bottommost point would be L omega. We all know that. Plus angular momentum of the rod. Angular momentum of the rod would be ml square by 12 plus m L by 2 whole square omega. This is the moment of inertia of the rod about the end A. This is parallel axis theorem. ml square by 12 is the moment of inertia about its center of mass or center axis, and this is mx square, the distance of point A from the center of mass. So simplifying this gives ml square omega by 2 plus ml square by 3 omega. So this is 6 2 ml square omega plus 3 ml square omega. This becomes 5 ml square omega by 6. Now, since there is no external torque applied, so the angular momentum before the collision will be equal to the angular momentum after the collision. So MUL by 2, which is the angular momentum of the system before the collision, would be equal to angular momentum of the system after the collision. By solving this, m gets cancelled, this one L gets cancelled, this is 3. So here we get omega is equal to 3u by 5L. This is the answer. This is a very important question with respect to JEE or NEET. There are many varieties possible, so you must understand this question very clearly.